Solve x squared minus 5 over x minus 4 equals 4x. You must show your working. So we need to solve this equation to get the value of x. Well, I can first get rid of the denominator here by timesing it with x minus 4 on both sides. So this will be, so you get rid of the denominator here. So you have x squared minus 5 on the left side, and on the right side we have 4x times x minus 4. Make sure you put it in brackets so that you're multiplying 4x to every term inside the brackets. So when you expand this term, you have 4x squared minus 16x. And here we have x squared minus 5. Now you can collect the like terms. I can take away x squared on both sides. So take away x squared. So to have, and then I add 5 on both sides. So that I have 0 on the left side. And this will be 4x squared minus x squared and minus 16x plus 5. So I have all these terms on one side of the equation. So 4x squared minus x squared is 3x squared minus 16x plus 5 equals 0. So we have this quadratic equation here. So let me write it down properly here. So we have 3x squared minus 16x plus 5 equals 0. So to solve the quadratic equation, we see the coefficient of x squared is 3 and there is the constant term 5. So when you multiply them, you get the product 15. And finding the factors of 15, you have 15 times 1 is 15, and when you add them, so because there is a minus sign here, so it's minus 15 minus 1 gives you minus 16. So I'm choosing these two as the factors. So I can write the same equation now as minus 16x can be written as minus 15x minus 1x. So in terms of these two factors. And then there is a 5 here. Now considering the first two terms and the last two terms together. So from first two terms we can take out the common number as 3 and a common letter x. So what remains now? 3x is taken out. You have x remaining. Then minus. You take out 3x. You get 5 remaining here. And from the next term we have x plus 5 remaining. So we don't see any common term. So we can take like minus 1 as a common term. Now what remains inside will be x minus 5. So make sure we are taking out minus 1 common. So this plus is a combination of 2 minus. So we have taken out 1 minus common. You're left with another minus 5 here. So that's a 0. So because addition x is added to 5 is equivalent to saying x is, you're taking away minus 5 from x. So that's why we have minus here. Now we have x minus 5 as a common term. And we have 3x minus 1 remaining here. So if x minus 5 is 0, then x is 5. And if 3x minus 1 is 0, then x is 1/3. So the answer is 5 or 1/3. A, B, C and D are points on the circumference of a circle with center O. BD is the diameter of the circle. EBF is tangent to the circle. So this is the diameter and the tangent. Give a reason why the angle BAD, that is this angle. So we need to tell why is this angle equal to 90. So why is this 90 degrees? Well, we know BD is a diameter and this is the angle subtended here. So that's the angle formed in a semicircle. So angle in a semicircle is 90 degrees. So angle BAD is 90. So angle in a semicircle is 90. Since it's for 1 mark, it's enough if we just write this as a statement. Write down one other angle that is 90 degrees. So what is the other 90 degrees angle here? Well, we know EBF is a tangent. So this the angle formed between the radius and the tangent is 90. So this angle is 90. The other part of the angle has to be 90 again. So you can write any one of those angles. I'm going with FBO. So angle FBO is 90 because it's the angle between the radius and the tangent to the circle. Next, it wants you to find the value of the angle CAD. CAD. That is only this part of the angle. Let me use another color here. It wants you to find this angle. Now, which of the circle theorems can we use here to find this angle here? There is this 35 and a 25 degrees here. We see this 35 is subtended by this arc BD. This arc DC. So arc DC has this angle here 35 degrees. The same arc is having the angle DAC also. So this has to be 35 again because they are the angles in the same segment. So I will write this has to be 35. Well, it doesn't want you to write the reason. Again, it's for 1 mark. So just you need to mention the size of the angle. But we know it's from the same segment here. Next is write down the value of angle EBA. So EBA, that means it wants you to find, let me use another color here, maybe this one. It wants you to find this angle, EBA. So now this is the angle formed between the tangent and a chord. AB is a chord here, you see, this is a chord. So this chord is subtending another angle here in the circle which touches the circumference to get here 25 degrees. So using the alternate segment theorem, this has to be 25 again. So I'm getting the value of the angle EBA to be 25 degrees. Simplify under root 160 divide by under root 2. So root 160 divided by root 2 is equivalent to the whole root 160 over 2. So now I can simplify this fraction. 2 goes into 60. 2 8 is 16. So it's 80. Under root 80. Now we can find it's, it's not a square number. So you can split it in terms of a square number and a normal number and a non-square number. So 80 can be written as 16 times 5. 16 5s is 80. So 16 is a square number for 4. And then we can have this like 4 root 5. So I have simplified this expression. Work out 1/8 to the power of 1/3. Now when you see the fraction in the power, it means it's a root. Now, which root to be more precise, since the denominator is 3, it's a cube root. So you have to find the cube root of 1/8. Well, 8 is a cube number. You get it by 2 times 2 times 2 gives you 8. So the cube root of 1 over 8 has to be 1 over 2 because 1 over 2 times 1 over 2 times 1 over 2 gives you 1 over 8. The answer is 1 is half. 2 raised to x times 4 raised to y is 16. Show that y equals 2 minus x over 2. So how can we come to this conclusion here, starting with the one which is given as an equation here? So we take the left side. We see the bases are not same here. And we can make the bases same by writing 4 in terms of 2. So we know 4 is like 2 square. 2 square is 4. So I can replace this 4 by writing it as 2 square. So this is 2 raised to x times 2 square. And there is this y in the power. This is equal to, again we have 16. 16 can be written as 2 raised to 4. Because 2 times 2 times 2 times 2 gives you 16. So this is 2 raised to 4. Now why I am doing this? Because I want to make all the base values same. So that I can use the index rules here. So here we see, now coming to this part of the expression, 2 power 2 raised to y. So this is like a power m whole power n. This is equal to a power m times n. So we can multiply these powers here. So we have 2 power x times 2 power 2y equals 2 power 4. Now for the left side, we see the bases are same and there is multiplication. We can add the powers. So because of a per m times a per n is a per m plus n. So using this rule, I can add the powers here. This is equal to 2 raised to 4. Now the bases are same and there is equal sign in between, then the powers has to be equal. This comes from the fact that if a per m is a per n, then m equals n. Okay, so let me write this clearly. So here, using this rule, x plus 2y equals 4. Now it wants you to show that we come to this equation from this. So what we can do is we have to make y as the subject of our equation here. So getting rid of x by taking away x from both sides, we have 2y is 4 minus x, and then we divide by 2 to get y is 4 minus x over 2. Now to have exactly this term here, we can separate out these terms. So 4 minus x, the whole thing divided by 2 can be written as 4 over 2 minus x over 2. So half of 4 is 2, and there is this x minus x over 2. So we have come to this thing which exactly it wants us to prove. So we have shown that using this equation, we have arrived to this conclusion. A sequence has nth term 2n square plus 1. Prove algebraically that the sum of any two consecutive terms in this sequence is always a multiple of 4. So here there are certain things we need to consider. There is this nth term here. So that means nth term is 2n square plus 1. Now what do we mean by consecutive terms? The terms which are next to each other. Next to each other are the consecutive terms. Like if I say the number 1 and 2 are consecutive, 3 and 4 or 2 and 3 are consecutive. So here for this terms in the sequence, it wants us to show that the terms next to each other, when you add them, the sum of the consecutive terms is always a multiple of 4. So we have to we have to show that if we add any two consecutive terms in this sequence, they have to be the sum has to be a multiple of 4. And we have to show this algebraically. Like you can't assume that n is 1 and then substitute the value of n as 1 or 2. Then you can get to the same answer, but you have to show it algebraically. So how can you do that algebraically without using any value for n here? Well, I can assume the n plus the next consecutive. If this is the nth term, what will be the next consecutive term? It has to be n plus 1th term. So I replace n with n plus 1 to get the next term of the sequence. So that is n plus 1 square plus 1. Right? Replacing n by n plus 1. And then I have to find the sum of these two and arrive at some conclusion. So let me manipulate this term first. So n plus 1 whole square, what does that mean? N plus 1 squared is equivalent to n plus 1 times n plus 1. Well, you can use the formula directly if you remember a plus b whole square. So if you don't, then you can look for this thing. So n times n times 1, and then we multiply every term here. So that you have n square plus 1 times n is n, and 1 times again n is 1. So that you have 2n plus 1. So n plus 1 whole square is equal to n square plus 2n plus 1. So I replace this value. So now taking the sum of the nth and the n plus 1th term. The nth term is 2n square plus 1 plus the n plus 1th term is 2 times n plus 1 square. I have made this as an equivalent expression for this. So that's n square plus 2n plus 1 plus 1. So I have expanded this term here to get this. Now what do I get here? So 2n square plus 1 plus, expanding this further, you have 2n square plus 4n plus 2 plus 1. Now collecting the like terms, we have 2n square plus 2n square, we have 4n square, and is there any other nth term? So there is only single nth term, which is 4n, and then the constants are 1, 2, 3, 4. So you have 4 as a constant. So this is the final sum we are getting when we add n and the n plus 1th term. Now I can factorize this. I can see there is this number 4 for every term. So I can take out as a common term. So 4 is the common term, n square plus n plus 1. Now this is, I can say that anything multiplied to 4 gives you the multiple of 4, is a multiple of 4, right? So any number times 4 is multiple of 4. So I have come to the conclusion that the sum of n of the consecutive terms for this sequence gives me the answer is a multiple of 4. So hence, I will write this as a final step. So consecutive terms, sum of consecutive term for the sequence, for the nth term of the sequence, n square plus 1, what's that, 2n square plus 1, is a multiple of 4.